someone at this conference that I was at. I mean, we all multitask. We do more than one thing at the same time, but we can't efficiently and effectively do, like, skills, motor skills we can. We can walk and talk and chew gum at the same time, most of us. But he showed this little PowerPoint thing, video thing, and he said, I'm going to give you 3 different stimuli, and it's all going to be related to bells. So I'm either going to show you a picture of a bell, flash up a picture of a bell, or you're going to hear a sound of a bell, or you're going to see the word bell. And as we go through this 30-second little video, you need to draw like a tick mark for every single time, like you hear under the sound, you put a tick mark. If you see the word bell, you put a whatever. And there were like, I don't know how many thousands of people in there, but there were only like a handful of people that got the correct amount for the sound, the word, and the picture. That's we can't multitask. All right, binomial distribution. I'm on the page that says the binomial distribution is used.
What order are we doing this? Because I have probability density functions in front of that. That's supposed to be behind it.
Okay, well, I'm doing binomial distribution next. Probability density functions are at the very back.
Okay. And so after binomial, continuous probability?
Binomial, there's, oh, you know what? I don't know. How did I order it on the learning portal?
Well, I went to print it out last night, and lesson 20, whatever the, normal distribution was like at the last one of the group of lessons, and then at the next group of lessons, the first one that I found was binomial distribution.
What do you guys have?
I have binomial and continuous.
You do?
Yes.
Okay, binomial is a discrete, and so is probability 2 distribution. I think what I wanted to do next was shoot, I don't know. Let's just do binomial distribution. There's Poisson distribution. Where did I put that? Do you have all of that too? The Poisson distribution and hello?
Yeah.
Okay, we're going to do binomial. Find the other one later. All right, binomial distribution is used to determine the probability of an event when, 1, there is a fixed number of trials. So you're going to toss a coin 20 times. 2, there are only 2 possible outcomes. I'm going to get heads or tails. Number 3, each trial is identical and independent, which means that, you know, I mean, other than if I'm going to toss a coin 100 times, fatigue is going to come into play, but we don't count fatigue. So we say that, you know, that each trial is independent. The probability of success is P, and the probability of failure is Q, where Q is equal to 1 minus P. So success would be I toss a coin and I get heads. That's a 50% probability. The probability that I fail would be I get tails, and that's 1 minus that probability. The probability distribution is given by, let me read this for you, the probability that x is equal to some number. Okay, I have a little x and a big X. Maybe I should use a different letter there. let's just use a 3. Probability that I get 3 successes is going to be the number of trials. Okay, have you seen this notation before? N choose 3. Okay, that's the combination coefficient, binomial coefficient, times the probability of success. I want 3 of those, and I want n minus 3 failures. Do we understand that? Mm-hmm. Okay, x is the number of successes in n trials, so here I have 3. And n over x is n choose x. So example 1, Mr. and Mrs. Smith want to have 16 children. Find the probability that they are blessed with exactly 5 boys. And notice I've said exactly 5 boys, because if I say 5 boys, then 6 boys and 7 boys and 8 boys and up to 16 boys would also satisfy that. But you want the probability that they're exactly 5 boys. So that's going to be 16 trials, choose 5. And those trials would be really considered trials literally and figuratively. Those are trials and tribulations. Probability of success is what?
P to the
Probability that you get a boy. What is P?
Oh, 1.5.
0.5. Okay, and I want 5.5s, and then I want 11.5s, right? I mean 11 0.5s. Right? I want 11. I want 5 boys. I want 11 girls. All right. So on your calculator, I want you to go to. I want you to do this notation, okay, before you go to the binomial distribution notation. So you're going to have to type in a 16, go math, probability, get that n choose 16 choose 5. And basically it's times 0.5 to the 16th, right?
Why is it 0? Why is there a 0?
Why is what 0?
This. On the packet. It says 0.
No, don't follow those instructions. Type in 16 choose 5 and then times 0.5 to the 16th. What do you get?
0.0667.
0.0667? Okay. All right, now, that's the way you do it. Now, that's the expression that I would write if I didn't have a calculator. Okay? If I do have a calculator, then I'm just going to go to the calculator, which already has the binomial distribution programmed into it. So go second bars, distribution. 0 should say binomial PDF. Oh, maybe it's different.
Oh, it says or A.
Wait, what?
Which one is that?
Go down, just keep going
Second
down.
bars.
After 0.
Oh. Okay, binomial PDF, right? Okay, or A it says. I'm sorry, I should have read that. Okay, so then you're going to go number of trials. How many trials? 16, comma, probability of success, 0.5, comma, how many successes I want? 5. So it'd be 16, comma, 0.5, comma, 5, right? And we should get 0.0667. Yes? Okay. Example 2, a manufacturer finds 30% of items produced are defective. The manufacturer selects 6 items at random, find the probability. Now, is this a binomial distribution? Are there only 2 possible outcomes? What are the 2 possible outcomes?
Defective and...
Defective or not defective, right? All right, so finds 30% of items produced are defective. The manufacturer selects 6 items at random, find the probability that A, 2 are defective. So I want probability that X is equal to 2. Now, this is kind of weird, but Being defective is a positive outcome, a success, right? Because he wants 2 defectives, right? Okay, so how many trials are there? 6, choose 2. I want, the probability of success is 0.30, and I want 2 of those. What would the probability of failure be? 0.7, and I want 4 of those. All right, so let's just use the binomial PDF on this.
So, what do you put in since 0.5 is both from the last
Here's the
one?
notation. Number of trials, probability of success, how many successes you want? 6, comma, 0.3, comma, 2. 0.324, okay, 32.4%, right? All right, B, a probability of at least 2 are defective. So for B, we want probability that X is greater than or equal to 2. Well, I can do this one of 2 ways. I can go probability that it's 2, 3, 4, 5, 6, and add them all up. Or an easier way would be to do what?
1
Negative
minus
1,
probability of
0,
0.
1.
That X is less than 2, right? Okay, and so this is going to be 1 minus the probability that X is 0 minus the probability that X is 1. Let's write this out. What's this going to be? 6 choose 6 choose 0, 0.3 to the 0, 0.7 to the 6, minus 6 choose 1, 0.3 to the 1, 0.7 to the 5. Go ahead and do that in your calculator.
Add 0.5798. Yeah, 0.680.
I got 0.580.
Yeah,
0.690.
Oh. Oh, yeah, he wrote it, yeah.
Okay, 0.580. All right. Example 3, given that 10% of us are left-handed, I have no idea if that's the normal.
Yeah.
Find the probability, how many of you are left-handed in here? Do you know about those guys?
They're not.
Kristen's
We're all right.
They're all right.
Timo is
7.
both.
Well, we already have 2
Some of
of
them
them.
both?
I think so. Yeah.
Timo is? Is Xavier?
No.
Xavier's right.
3. So 2 out of 3 out of 11.
Who's 3?
Timo?
Jimmy's like, no.
Is he like ambidextrous?
He is.
He
his
was
Yes,
left-handed
right,
and then he got
mostly.
like beat into it.
Oh, wow. Really?
Yeah, my mom tried
Beat
to
into
do
being
that.
right-handed?
Yeah, my mom tried to do that with
Okay.
me and didn't work.
Oh, really? Why? Is it just not socially acceptable to be left-handed? or-
Well, you know, back in the old days, people who were left-handed were
It's Asia.
considered lame because the left was associated with like the devil.
Oh, really?
Yeah.
Wow, that's
Like, I read a
interesting.
book about a kid that like there's a really good picture with his left hand. His
Yes.
father was like
Oh, yeah, we didn't read
religious.
that. Yeah.
Yeah, it was like St. John's. And his father was really religious, and so he would beat him every time he like pitched with his left hand.
Oh, my gosh.
But he sucked with his right hand, so it wasn't very good baseball.
Oh, wow. That's a bummer. Okay, so find the probability of choosing exactly 3 left-handed students in a class of 15 students.